So for my project, we are looking at load carriage during gate. And before we actually get to the equipment setup, what we've got to do is we actually have to move one of the force platforms. As we can see right now, they're sitting side by side, which is not ideal for gate. We would want them to be more in line so that we can get multiple foot strikes. And what we're going to do today is we're actually going to move dark gray. And the way to do this, there are little eye hooks that go into the circular fillings of the force platform. You screw these guys in and pull them straight out. And then inside of where the fillings are, there is an Allen head screw in there that you just unscrew with the Allen wrench. You can screw them all the way out. They stay within the force platform though, they do not come out of the hole. When you get a free spinning feel, you know that you are completely disconnected. And then what we have to do is we're going to move it in line with light gray, so it will be in the empty spot there where the box used to be along the rail. And all we're going to do is slide it back and then move it right over. The one thing we need to make sure we do not damage are these metal railings. They are cut specifically for these force platforms, so we do not want to damage them in any way, shape, or form. So now as we can see, dark gray has moved back in line with light gray. We had to move some of the other boxes to make sure that it would fit. One of the most important pieces to be aware of when you're moving the force platforms is that these kind of cables do not get pinched. So this is part of dark gray that connects to all of the hardware going into the computer. So we need to make sure that this doesn't get pinched or impinged by the force platform or any of the boxes. So we'll just tuck this guy back underneath. And then we will lay the filler boxes directly over it so that we do not damage the cord. Alright, so now for a more complete look, our floor is entirely put back together and we have the two force platforms that are now in line, which work very, very well for gait, for walking. So we don't have to worry about trying to hit one force plate. Now we can hopefully get 2 foot strikes or multiple foot strikes with this configuration. So now that we have the force platforms moved, we will begin looking at the hardware that needs to be set up appropriately for use of the force plates in conjunction with the Vicon system. So we have all seen this table before with all the equipment on it, but since we're just going to be focusing on the force platforms at the moment, excuse me, I just want to reiterate that this is the charge amp for the dark gray force platform, which is a little bit older, which is why we need this piece of equipment. This increases the voltage so that when it goes through the patch panel and A to D board, it's actually a signal that's usable. So this is the BNC cable from that force platform. And then this is the output, and as we can see, it kind of winds around here and goes into the patch panel, where it will then be transferred into the Vicon computer. Now for light gray, for the newer force platform, the input comes directly into this Kistler box, this DAQ box, and this large plug on the right side is the import. And then out here are all of the out ports, so all of the different signals, forces, moments, and everything like that. Those also bleed into the patch panel here, which once again, following the cord, the white cord, goes right into the Vicon computer. Now that we have all those set up, we are fine to collect force platform data with our Vicon. So next we're going to move on to how to set up the Vicon system. Alright, so this is the Vicon box, where all of the important pieces of Vicon are housed. As we can see, there is a bunch of cable that's up on top of the Ultranet. This is so that we can move any of the cameras basically wherever we want within the lab. Obviously, however long the cables are determines where and how far away the cameras can be moved. But we have that luxury of being able to move them should we need to. Now, if we look down at these BNCs, these are all of the cables for each of the cameras. Now, there are 10 ports, and they're all taken up by the 10 cameras here. If for some reason we had 8 cameras or a lesser number of cameras, we obviously wouldn't have these ports filled in. And then if we look, this is the same white cable here that is from the patch panel that has both of the force platforms on it. And as we see, it is plugged in directly into the Ultranet as well. And this is so everything is synced up through Vicon, force platforms, motion capture cameras. This way, when we collect our data, we don't have to externally synchronize it. It is synchronized within the software, which makes it much easier from an analysis standpoint and from a collection standpoint. Now, in order to turn this on, we typically turn this off when it's not in use. There is a power button right here, and we will just click it on, and we hear the sound of the fan turning on, which means we are almost ready to collect. And now we're going to move up to the computer piece of collecting in Vicon with motion capture cameras as well as force platforms. Alright, so now that we have most of the technical things down for Vicon and force platforms, we are going to open up the software. Now, there's a new version of Vicon Nexus that is up here. It is Vicon Nexus 2.2.3. However, I'm a creature of habit and I don't like change, so I like to stick with the good old Vicon Nexus 1.8.5. In my opinion, Vicon broke it when they tried to make it better, and I just like the older software version a little bit more. So we're going to go ahead and open this guy up. And as we saw in class, and through many of our data collections, this is the main screen that we come up to. It doesn't look quite as pretty in 1.8.5 as it does in 2.2.3. However, to me it's more functional, and as a biomechanist, I just want things that work as opposed to trying to make things work that don't really work. So from here, we're still not quite ready to collect any data. One of the first things that we'll need to do is to calibrate the system. As we can see, there are random markers in the capture volume that really don't need to be there. So as we kind of spin it around, we can see what other kind of things are going on. So there's just a few markers that we'll need to get rid of. But most importantly, we have these force vectors that are coming out of the force platforms that are not entirely appropriate. So as we can see, they're going down, and there's no one standing on them currently. So we will need to fix that as well. Now, rather than filming the entire calibration process, I will go ahead and do that, not on camera, mainly because no one probably wants to see that couple minutes of action. So I will go ahead and calibrate, and then we'll come back and set up a subject to collect. Alright, so I just calibrated the cameras, but as we can see, there's still something not correct. There's a camera that is below the floor, one in the floor, and then one acting right on the force platforms. So what we have to do is we have to set the volume origin so that all the cameras know essentially where our 000 is. To set the volume origin of the lab space, we need to use the active wand, and we actually set it on the corner of where dark gray used to be, so that our positive Y direction is going to be that way, and our positive X is going to be that direction to the right. And then once we do this, we need to click the Set Origin button in the software. And here's that button, so we will click this, and then we'll click Set Origin, and we are ready to go. Now we can look at the capture volume, and we can see that all the cameras are a little bit more appropriate. They should be in the right place now. So what we'll do is we will move on to setting up a subject in Vicon and how we make sure that we have everything that we need for us. Alright, so to set up a subject, we need to first click this button in the top left corner of the software. This will open the Eclipse database, which is where all of the previous trials have been collected, all the different projects. So since we're in load carriage, we can see that it is highlighted blue, so now we can make a new subject here. And after we have this green dot, this project made, we need to come up and click the subject button, or new patient button. So we'll click that, and we can see new patient 1. We'll leave it there, we'll hit enter. And then under new patient 1, we need to start a new session, so it's going to be the next button. We click that, and we can see new session 1. So once again, we'll click that, and we are ready to go. Now we'll come back over to Vicon, and in the Subjects tab on the left-hand side of the software, we are going to click the middle button, which says This will tell us what marker set we want to use. And you can see there are a bunch of different marker sets. So what we're going to do is we are going to use the Jeff lower extremity cluster and trunk model. And when we click that, it's going to come up with the patient name that we entered in the Eclipse database. And this is fine, new patient 1. We'll just keep that. And then here we can see that we have a model that is attached to it, all of the markers that will be used for this subject. And currently they're all grayed out because there's not a trial to label these markers with. Now, before we move any further with our collection, we need to make sure that our force platforms, light gray and dark gray, are zeroed. If we remember previously, there were force vectors going everywhere. So what we need to do is we need to highlight both, right-click, and hit 0 level multiple. Now when we look, there aren't any more crazy force vectors without anyone standing on the force platforms. To set up our subject and to calibrate our subject, we're going to be in the Tools section of Vicon on the right-hand side of the software. And we're going to click the Subject Preparation button, and in here we can see Subject Capture. This is going to allow us to take our static calibration with all of the markers on an individual, and all that we need is about 1 second's worth of data, really just one frame of them not moving. So we can click that, and then we'll hit Stop. After we've collected our static calibration, we need to come over to the Reconstruct button. And what that is going to do is it's going to run a pipeline that tells the system where all of the markers for the subject are. Now, as we can see here, there are a bunch of markers that are simply just gray dots throughout the legs, the feet, the pelvis, as well as the upper body. Now, these are not labeled, so what we have to do is we have to go through and label them. To do that, you come up once again to the Tools bar of Vicon, and you'll click kind of this aptly pictured label button. When we do that, we'll see all the previous markers that are in our model that we are going to apply to this subject. And to do this, all we do is we click one, and now we'll see that it's the right shoulder, which for this individual, we can pivot him, and we'll see now we're at a posterior view, so we have the right shoulder, and the nice thing is that these will cycle through. So left shoulder, the clavicle, and then the sternum. And once we're through labeling, our model will look something like this, at least for this project. So we have our trunk being modeled by both the chromium processes, the sternoclavicular joint, and then the xiphoid process. And then on the lower body, we have the pelvis, we have 4 marker clusters on each of the lower extremity segments, so for the thigh, the leg, bilaterally, and then down on the foot, we have a heel cluster and a toe marker, as well as the malleoli. Now that we've collected this, we are actually in a great position to begin collecting some data. To collect our data, we'll once again be working over in the Tools bar, and you're going to click the Capture button. Now here, you can name your trial whatever it needs to be named for your specific project. And you can add a description as well as some notes. For instance, if you have a trial that's no good, you can go back and put like a DNU for do not use. If you're describing something, if you have a different condition, you can note that as well. Now what's really nice is that Vicon will auto-increment your trial number. So here we have loaded _L_4. What Vicon will do is after we collect this trial, it will go to loaded _L_5. Now, what can get you in trouble is if you only use a single number like we have here. When you get to 10, it may potentially override your previous trials, or it won't collect at all. So one way that you can do this is you can use, in this instance, loaded _L_04 or _004. That way you have plenty of numbers that you can have for trials. Now, another option Vicon gives us is to override existing files. So right down here. Now, this probably isn't the best button to check, unless if you're just piloting some data. However, I would recommend not checking it just in case. Now, once you have your trial name, and if you need a description or notes, all you have to do is click the Start button down here, and when we click this, we'll see the frames run by, and then when the trial is over, you stop it. Now the length of the trial obviously depends on your movement. For this trial that we've just collected, I will go ahead and play it, and we can see the individual step on the force platform and off. And really all we need is a strike on the force plate to the ipsilateral side striking the ground again, so we have a complete gait cycle. Now this is a labeled trial, separate from the just marker trajectories that we had before. There are a couple different ways to do this. The way that I like to do it is I manually label the trials, mainly because my trials are not very long and they're pretty simple. Another way that you can do it, however, is by using Vicon's reconstruct and label pipeline. However, that has a tendency currently to not be very accurate and to leave a lot of holes in the marker name trajectories, which kind of creates some issues with labeling anyways. So to mitigate that, I simply just label the trials by hand. Now if we play this trial again, we can see that not only do we have the Vicon model walking, but we also have the force platforms that are generating a force vector that we can see in red right about here. So the combination of these two really help to discern how the body is moving due to the added weight of the load carriage. In this case, it was 7.5% of an individual's body weight, which is well within safety guidelines for most individuals. Once you have all of your trials labeled appropriately in Vicon, you can export the data from there, but really you just get marker trajectories, and it's not as robust as some other softwares that we currently have. So what I'm going to do is I'm going to show you the basics of using Visual 3D, which is a biomechanical software that was built by biomechanists for biomechanists. And just a real brief rundown. The first thing that we see over here on the left is our static calibration. So that's when we had our subjects standing by themselves, arms out to the side. And then just to the right of that, underneath that motion file tab, are all the trials that we collected. So we have loaded L1, loaded L2, and so on and so forth. And what we do here is we actually create a whole new model due to the fact that it's a different software that tells the software what the markers mean, where they go. So here we have a skeleton trunk, pelvis, bilateral femurs, bilateral tibias and fibulas, as well as feet. Now what we do is we will actually apply this model, similar to how we do it in Vicon, to our motion trials. Now just like in Vicon, we can play the trial, but now we do have the skeleton attached to it. So we can watch as the skeleton walks over the force platforms, once again at a fairly nice, slow rate. And we can see what's going on with the force platforms. We can see the blue ground reaction force curve coming up, showing us where the force is being applied. Now what's very, very nice about Visual 3D is that we can actually plot our joint positions or our joint angles, and we can trace it as the skeleton walks. So as we see on the left, the skeleton is moving, and on the right, we see the plots up at the top, the hip angle, middle, the knee angle, and the bottom, the ankle angle of the right side. So we can see those synchronously, which is very, very nice. Now another very cool feature is that we can plot our ground reaction force curves. So we can see when the individual steps on the plate, watch the trajectory of the vertical ground reaction force, and plot it as well. Now it doesn't do us a whole lot of good just to plot them and watch the skeleton walk. So what I've done is I've created what's called a report template. So we see on the right hand side, these are the lower extremity kinematics. So we have the hip angle, the knee angle, and the ankle angle bilaterally. And now because this is load carriage, there is unloaded and loaded conditions as well, which can't be seen on this video due to the similarities between the two conditions for this individual. Now if we look down at the bottom left, we can see that there is a page for trunk kinematics, lower extremity kinematics, moments, joint powers, and ground reaction forces. So if we click through these, we've already seen kinematics, so here's the trunk angle. We can see that there is a difference in trunk angle between the two conditions, with the red being unloaded and the blue being a loaded condition. And then here are the joint moments that are kind of ugly, but we didn't have a lot of trials to really kind of smooth out these peaks and these valleys here, although they do still follow pretty interesting patterns. And then here we have joint powers bilaterally, so the absorption or the production of power or generation of power. Now, how did we get all that data? Well, that's a fairly loaded question that is a graduate class all on its own. However, what you do is you actually write a program similar to MATLAB that tells the software exactly what you're wanting to calculate. So all of these items in this box that I'm scrolling through are things that I've told the software that I want computed. These are all of the joint angles, all the filtering for the kinematic trajectories, the force platform, interpolations. Every kind of filter that I've needed for my data has been done here. Now what I want to show you, because once again, if it's in the software, we can't really do very much with it. So what we have to do is we have to export all of these data to an ASCII file or to a text file. And that's what these different cues are telling us. So we have selecting a certain file type. Since I have loaded and unloaded conditions, I had to select them appropriately. Otherwise, my ASCII files would kind of be a disaster. And to make it easier on myself, we just don't do that. Now, what I have to do here is I will actually execute all of these different commands to export the data. So when I export these, I have them going directly to my flash drive. And as we can see, I have load carriage GRFs up the very top two, and then I have trunk data as well as just load carriage data, which is just my lower extremity kinematics and my kinetics, so my joint moments and powers as well. And as you can see, I've already opened a couple of them and saved them as Excel files. And in Excel, I can manipulate my data, I can graph, I can plot again, I can extract any variables that I need to at any explicit discrete points so that I can perform my statistical analysis. So that was a very short, brief crash course into Visual 3D and its usefulness, and kind of the use of motion capture with force platforms from collection all the way through analysis. Now, unfortunately, I won't get into the manuscript writing piece. However, I feel that having a basic knowledge of Visual 3D will be very helpful in any of your biomechanical research endeavors. I hope that this tutorial was very helpful, and if anyone has any further questions regarding any of this that I've just talked about, please contact me. I would be very happy to help you. Thank you very much.